Hello, my name is Rodrigo Garcia, and I work with ESP32 framework development within Expressive. Today, we will talk about how to build Arduino as IDF component projects. We'll talk very quickly about Arduino. I will show you an example. We'll talk about how to add libraries and how to use CDC and log messages. What is Arduino? What is its relationship with IDF? Arduino is a project that makes easy to use embedded software that has an IDE integrated with a toolchain and bootloader, which makes very transparent for users to integrate that parts. Users will use an IP, which is the Arduino API, and that API will allow those users to include modules, external hardware, such as sensors, displays, and LEDs. That was initially thought about using for designers and artists, but it got very popular, and today it's used in every place. So the API is very easy to use, and it deals with digital pins and analog pins as well. It allows you to communicate with different modules, and it also is based on C++. We will not talk about Arduino here, but you can see many tutorials and examples provided by the community that are out there in the web. The relationship of Arduino and IDF is that there is this Arduino HAL level in the middle, which is a middleware that makes the communication from the upper level, which is the Arduino API that has all the APIs for Arduino, and the lower level, which is IDF itself. All of that has also free RTOS available for you. If you need more information, you can go into that specific link. Arduino as component is basically an IDF project. It uses IDF tools. In terms of IDF, you have your project, which usually has an SDK config file. This file is automatically created when you're building your IDF project, and it's based on the settings for each one of the components of the framework. Arduino has its own SDK config, and you can find that SDK config for the version 3.04 in the first link, and for the version 20x in the second link. You can use that SDK config in your project if you want to. In particular, the examples here are for the S3, but you'll find all the SDK config files for all the other SOCs. Once you have your SDK config there, you can use IDF PY menu config, which will open a window that allows you to browse through all the settings. You can change them, for instance, partition, scheme, or flash size, and then you save it into the new SDK config file, and you start building your project by setting the target, which actually was done before, and then you just go through a building process and flash your chip. This is exactly how we do with an IDF project. There is no difference. IDF and Arduino has a very specific relationship in terms of versioning. So each Arduino core has its own IDF version. You can check that on the release notes from Arduino. Here I have a list of the different core versions and the IDF versions used by them. IDF projects usually use the ESP component registry, which is a central repository for all the components that are provided by Expressive and also by the community. You can check that in that link. In order to add a component, you will modify IDF component.yaml file and declare all the dependencies there. In particular, Arduino framework is one component in the registry. So in our examples today, we will use that. You can also clone your own Arduino in the components folder of your project. In that case, you would not use the component, the managed component here from the registry. Let's show you a basic example now. This is the folder structure used by Hello World, which is the minimal example possible. You have your project folder here with different files, and one folder main, which will contain all the source code. We'll go through all the files in a minute. So the project CMake list.txt file is a generic and global, let's say, declaration of CMake for your project. Remember that IDF projects are built using CMake. So you will request a minimal version. We'll include all the tools necessary, which are IDF functions for CMake, and we'll declare the name of the project. We also have the SDK config default file, which has all the SDK settings for our project. Those settings will override the component settings coming from IDF. In our case, we have the auto start Arduino as yes, which means that it should use setup and loop routines to start the application, the sketch itself. And also we set the frequency of FreeRTOS for 1 kilohertz, which means that each tick will take 1 millisecond. If you need to add more configuration, you can to that file, no problem. And if you need to check what are the differences between what you have added here and what comes from IDF framework, you can use the command idf.py save def config, which will automatically create this file for you. We have, as I said, the main folder, which has all the source code of your project. There we have an IDF component YAML file, which might declare the dependencies of all the components from the registry that we might need in our project. In our case, we are just declaring the Arduino framework is our dependency, which will make the tool to download it automatically from the registry. We can pick a version saying what is the version and the clause version. Here in the example, I'm using the latest one by using a star as version. It also has its CMake list.txt file, which declares all the source code. In our case, we have just one file, which is main CPP, and this main CPP has the sketch itself. And any include directories will be in the same place of the main folder. If you have more source code, you need to declare the list here. Our main CPP file, which is our sketch, is very simple in our case. It has the setup and loop functions, basic from Arduino, and that only opens the serial port, prints hello world, and waits for 1 second. It will be done in a loop, meaning that it will print hello world every second. Once you're done, you need to use the IDF tools to build the project. In order to use the IDF tool, which is idf.py, all we need to do when we just create this project is to set the target, which will be ESP32S3 in our example here, and execute flash monitor or just build in order to build it or flash and see the output of the serial port. If you change your target, it might require you to remove the build folder and also to set again the target. Don't forget to delete the SDK config file because that file has a declaration about what is the target. So when you build it, it will take the target from the SDK config file. So if you change the target, delete build folder and SDK config file as well. You can use menu config to change any setting again if you need to. That's why keeping your default settings in the SDK config.default is important. Let's talk about how to add libraries to Arduino project. In the case of Arduino as IDF project, we have 3 kinds of libraries. One is the libraries that are embedded in the Arduino framework itself. There is nothing to be done here. All you need to do is use them. You can use the examples from the Arduino core in the GitHub and run them, build them directly from there. Everything is set up already. You might need to use some external libraries from Arduino community, which are those used for displays, LEDs, sensors, and some other external hardware. In that case, all you need to do is create a component. For that, in your project folder, you should have the component folder. In that component folder should include a folder for the library. You clone the library there, or you copy the files or the folder, the whole structure there. The only thing you need to add is a CMake list txt in order to provide CMake with the list of source code for that particular library. The third way of including a library into your project is using the registry. The managed components here can be used because we can mix IDF and Arduino code in the same code. In order to include any component, you just declare it in the IDF component YAML file, which is in your main folder. Everything that you bring from the managed components should never be touched or modified. It's managed by the system. So if you need, for any reason, to modify your component that comes from the registry, you need to copy that from the managed components folder to your components folder, which is your local group of components. So there you can modify anything. If you try to modify any source code in the managed components folder, the system will complain about it and will not allow you to build the target. This is the structure, the folder structure for the libraries. So as you see, you have the same I have talked before in the example, in the Hello World example. And we have this extra components folder where we have one folder for each one of the libraries we are using. You can have many libraries as you want. And for each one of the libraries, we should have one CMake list txt file that will say what are the source codes for that library. This is an example where we are using the Wi-Fi Manager library, which is an external library. You can see the GitHub for that library. And all we need to do is go to the folder for the project, create the components folder, go into the components folder, and clone that library there. In particular, that library has already a CMake list txt file, but we need to modify it. The modification is just telling the system where exactly is the Arduino framework folder. Because we are using the registry, and the registry will install automatically the Arduino framework into the expressive __ Arduino-ESP32 folder, which is under the managed components folder of your project. If you, for any reason, use your own copy of the Arduino framework in the components folder, you should replace that name by the name of the folder you have cloned your Arduino framework into. Also, it might be interesting for you to add in the SDK config default file one setting, which is to tell the system that should not care about the idle test for CPU1. This is the one which is in the middle here on the screen. This is interesting for the ESP32 and the S3 because they're dual core, and the system might complain because CPU1 is idle, a task is not being reached, mainly because of Wi-Fi. So that is also in the SDK config from Arduino as default there too. But in your project, you might want to declare that explicitly through the SDK config.default file. Now we will talk about how to use the USBCDC. When we have a Arduino's IDF component project, we can use the serial object, which is usually the UART0 port. Some boards, they might have native USB port there, and you might, in that one might be the only one port, by the way, of that board. You might want to use that port in your project. In order to do that, all we need to do is to declare two symbols, which is Arduino CDC on boot equals 1, and the Arduino USB mode equals 1 to tell it it's using hardware CDC. If we declare that it's 0, it will use the USB OTG. The hardware serial is a specific implementation in hardware for only CDC class of USB. It's available in the C3, C6, S3, H2, and P4. And when you do that, two defines, your serial symbol will be attached to the hardware CDC port. In order to declare those two defines, you go to the cmakes list.txt file from your main project folder and add those two lines that will just do as define those two symbols as 1 and 1. That's all you need to do. The way how Arduino works with that is that it has a hardware CDC class in its framework, and that hardware CDC class has an object called hardware CDC serial. When you set Arduino CDC on boot to 1, serial will be defined as hardware CDC serial object. Therefore, it will act exactly as the serial from Arduino, but everything will be outputted to the CDC port. Don't forget to set the mode to 1 in order to use hardware CDC. When you upload any sketch using the USB port, it might be necessary to make the SoC enter into the boot mode, into download mode, I mean. In order to enter into download mode, you need to hold the boot button and then pulse reset, meaning that you press it and release it very fast. That will make the SoC enter into download mode. You download your sketch and your firmware to the SoC, and at the end of the operation, you just press reset to start the firmware. If you want to use OTG USB, which is only available for the S2 and S3, it's very similar to the other process, but you need to set the mode to 0 and the cmake list.txt file. And also you need to add the tiny USB component here, which will be cloned. How to clone it? You basically go to your project folder and execute those two lines of command. You'll clone ESP Arduino Lib Builder into the project folder, and then you clone the tiny USB project into that too. That's all you need to do, and just build it and flash it. Now we'll talk about debugging. Debugging meaning that how you send log messages out. When you're talking about the log messages, you have three options. One is the bootloader messages. The other one is the IDF component messages. And the third one is the Arduino log messages. There is one log level for each one of those three different places. So in order to modify that, you can use idf.py menu config, go into the menu, and go through these different layers of the menu and modify the level of the log messages. The other way to do that is also by changing your sdkconfig.defaults file to include what is the level for each one of those parts. This is an example of how to change the debug level for Arduino. You selected, this is the menu config screen, so you just selected Arduino configurations, you go to the debug log configuration, the full log level, and you'll see this screen. You can select one of those levels, which means no output at all, error messages only, warning messages, info messages, debug, and verbose. You just go out, save it, and build your project if you need. How the debugging works with Arduino in particular? Well, the serial object, anyone from serial or serial 1 or serial 2, which means you are 0, you are 1, or you are 2, you can set one of those to output the log messages here. And in order to do that, you just use this method, which is set debug output to true, using the serial object that you want to use for login messages. In case you're using CDC, remember that serial will be the CDC port, OTG, or hardware serial that you're using. In that case, the message will be outputted to the USB as well. In some cases, you might want to use only serial 1, which means UART 1, or serial 2 when that is available, as serial 2, and output on those other ports, other log messages. You can select the level of the log message by using the log dash underline the level. So error is E, warning W, info, debug, and verbose. When you set the level on the menu config, only the messages that are on that level will be outputted. All the others will not. So you need to select the correct log level that you want. This is all I wanted to talk to you, and I hope you have enjoyed. This presentation is available in this link in the GitHub. And also, there are other examples I have exposed here, there as well. You can just clone that repository and go into each one of the examples and build them and look into how it was done. You can see all the configurations I have talked here, there as well. Thank you for watching, and now we go to the Q&A session. See you